So for our notes, right? We've been talking about displacement. We've been talking about velocity and acceleration, right? Now, the only trick is that we haven't talked a lot about graphing. We talk about data, but we haven't talked about the actual graphing of it. And a very important scale in the graphing is slope. So we're actually going to talk about slope real quick and talk about its importance when it comes to these motion graphs, okay? So let's start off with the definition of slope, okay? So we're on slide 21. So slope is a number that describes both the direction and the steepness of the line. Okay, I'll make this a little bit bigger so you guys can see them. So a slope is just a number that tells us what direction and how steep the line is. So steep means like the height, like the angle of it. Is it a pretty high angle or is it a pretty low angle? That's what the steepness means, okay? So it's a number that describes both the direction and the steepness of the line. Now, as far as an equation expression, the slope is the change in y over the change in x, okay? Change in y over the change in x. The delta stands for change, right? The change in the vertical axis, the y-axis, and the change in the horizontal axis, the x-axis, okay? Now, we're going to focus on two specific graphs. We're going to focus on displacement, and we're going to focus on velocity. Now, for the displacement graph, if you get a displacement graph and I ask you to find the slope, you're actually trying to find the velocity for me. So when you have a displacement graph and you're trying to find the slope of a specific section, you're actually trying to find velocity. You're actually trying to find velocity. Likewise, if you have a velocity graph and I ask you to find the slope, you're actually trying to find acceleration. So the slope in a displacement graph is velocity, and the slope in the velocity graph is acceleration, okay? So displacement is the change of meters per second, which is velocity, and velocity is a change in velocity per second, which is acceleration, okay? Now we have three examples of slope. We have a positive slope, a negative slope, and a zero slope. You guys already know what this is. There's three types of slopes. There's a positive, a negative, and a zero slope, okay? So this is how we're going to be able to tell if the number is going to be positive or if the number is going to be negative or if the number is going to be just a zero. Going to scroll down a little bit as well. Let's look at some examples. Let's look at this example right here. We have some values on the x-axis. We got some values on the y-axis. We got a positive slope. The reason I know it's a positive slope is because it's going up over time or over the destination. So I know it's already know it's going to be a positive number. Now to find the slope, you grab two values and you try to find out the different space between both of them. So if I start right here at this coordinates 2, 2, and I try to go to this coordinates 4, 4, I know I have to move two values up the y-axis and two values to the right of the x-axis. So I get my change in y is positive 2, and my change in x is positive 2. So what's 2 over 2? 2 over 2 is 1. So the slope for this example is positive 1. The same thing goes with this second graph. Now we have a negative graph, and we start at these coordinates 2, 4, and we're trying to end at the coordinates 4, 2. So I know I'm moving my y-axis 2 down, so my change in y is 2 down, which is negative 2, and my change in x is positive 2 to the right. So my slope is going to be negative 2 over positive 2, which is going to give me negative 1. That's going to be the opposite of that first graph right there. And lastly, this last graph is going to be just 0. The reason it's just going to be 0 is because I'm not moving up or down. As you can see, I can go up any numbers and I can't go down any numbers. So no matter what the x-axis, the change in x-axis is going to be, it could be a million. It doesn't matter because my y-axis, the change in y, my numerator is going to be 0. So any number that has 0 that's divided by any number at all, no matter how big or small, it's still going to be 0. Okay. Lastly, let's look at two examples, at two specific graphs. If the numerator and the denominator aren't the same number, then the same thing still applies. So if the numerator and the denominator aren't the same number, you just try to solve for it. Whatever you do, you just try solving for it. Okay? So the number could be different. It could be a different number, which we're about to find out in a bit. So look at this. We got a displacement graph and we got a velocity graph. The reason I know this is because we got dt, which is displacement, we got vt, which is velocity. So in this example, let's look at the highlighted part. I'm trying to find the slope of this highlighted part and look at my x and y axis. My values are now jumping by 2. They're going at a rate of 2. So when I move 2 up, I'm actually moving 4 up from 2 all the way to 6. And when I move 2 to the right, I'm actually moving 4 to the right from 2 all the way to 6. So I'm increasing by 4 and I'm increasing by 4 to the right. So the change in y is 4 and my change in x is 4. And since this is a displacement graph, my velocity is going to be, my slope is actually going to be my velocity, which in this case is going to be 1 meter per second. Okay, because to find the slope of a displacement graph, I'm actually trying to find my velocity. And since I went up 4 and moved 4 to the right, was 4 divided by 4, it's just positive 1 meter per second. Just 1 meter per second. And someone just asked me about this. What happens if the numbers are not the same? Well, here, let's see what happens when the numbers are not the same. Now let's look at this velocity graph. Let's try to find the slope of this highlighted part. I already know it's going to be a negative number because the slope is actually negative. And I know since it's a velocity graph, whatever my slope is, I'm actually solving for acceleration. Okay. So in this case, I'm moving, my y-axis is, my change in y-axis is -2, and my change in x is +4. So what's -2 divided by +4? It is -0.5. Oh, some time. -0.5 meters per second per second. So my slope is negative. So that means my acceleration, I'm actually slowing down. -0.5 meters per second per second. Yes, if the y and the x are not the same number, if the change in y and the change in x are not the same number, then just solve for it. Yeah, just solve for it. The examples I gave you were all the same numbers except for the last one, and all I did was just solve for it. -2 divided by +4 is -0.5. We're going to move to slide 36 now. Please give me a check mark once you're there. We're on slide 36. Sorry, so slide 36, which is level 1, slide 37, which is level 2, and slide 38, which is level 3. It's just a level of difficulty. Awesome, thank you so much, Angel. So let's start with this one right here. You're going to choose one level. You're going to choose either you're going to do level 1, level 2, or level 3. It's up to you which one you want to do. Your instructions is to drag the correct velocity versus time graph to the corresponding displacement versus time graph. So right here we have a displacement graph, and right here in the bottom we have a velocity graph, which you can actually just drag. You see that? You can just drag them. Now I want you to find which of these graphs will go with the correct displacement graph. So for example, you need to pay attention to the slope. So look at this first one right here. The slope of this graph is just 1 meter per second. It didn't change. It's just 1 meter per second throughout the whole entire time. So if the slope does not change, if the slope is constant, which graph will be the correct graph for this first one? Does anyone know which graph will be the correct one for this? Thank you, Lourdes and Jocelyn. Yes, the first one, because look, since the slope did not change, that means my velocity did not change either. So it's just 1 meter per second, okay? So I want you guys can use your notes, like slide 30 has some notes for you. You can also use the notes from last week. If you go to slide 19, there's some examples right here from our notes from last week as well. Use your notes to do it, okay? So in the chat box, tell me which one you're going to use.
Let's go over some of the examples. We know the first one is going to be 1 meter per second throughout the whole entire time because the slope does not change. Remember, the slope for displacement graph, the slope tells you what the velocity is. And the velocity, the slope of the velocity tells you what the acceleration is, okay? So on this first one, the slope is 1 meter per second. So that means velocity is 1 meter per second throughout the whole entire graph, okay? Now, let's look at the second one. The object moves at a pace of 3 meters per second, but then it stops at 0 meters per second. So which graph, which velocity graph do you think will be the correct one? Do you think it will be the one on the left, the one in the middle, or the one on the right? Or in this case, do you think it's the first one, the second one, or the third one? I'll let you guys get a chance to put in the chat box. Awesome, getting a lot of consensus on this one. Thank you, Emily, Jocelyn, Fernando, Karim, Annalise, Lourdes. Thank you for right off the bat for answering that question. I'm gonna wait for a couple more people in case they have it. Thank you, Rosalinda, for answering. Once again, it starts at 3 meters per second, the slope, and then it decreases to 0 meters per second. So the consensus was indeed, you're right. It was the second one, the one in the middle. It's a good job. The reason is because, look, it starts at the slope, right? It's 3 meters per second. So in velocity, the velocity starts at 3 meters per second. And then what happens? Boom, decreases to 0 meters per second. Okay. Oh, my bad. Uh-oh. How about the next one? The third graph right here. The slope starts at negative 2 meters per second, and then it increases to 1 meter per second, but then it stays constant at 0 meters per second. So we go from negative 2 to 1 to 0. So which velocity graph reflects that? Do you think it's the first graph or the third graph? The left graph or the right one? First, third, left, right. Which one do you think is the correct one? Thank you, Karim, Fernando, Lourdes, Annalise, Emily, and Jocelyn. Gonna wait for a couple more scholars. The left one or the right one, the graph number 1 or graph number 3. I should have labeled the graphs, I'm sorry. Thank you, Anke Gabriel. Thank you, Rosalinda. Okay. So for this third graph, it's actually going to be the third graph, the one on the right, because you start at negative 2, right? So you start at negative 2 meters per second. Then you increase to what? 1 meter per second. So you go all the way up to where it has the 1 meter per second. And then what happens? You move to 0 meters per second. You see that? So negative 2, 1, and 0, which means the first graph will go with the last one because you start at 0.5 meters per second. Then you decrease to negative 3 meters per second, but then you increase to 0. So you go from 0.5 to negative 3 to 0. So in velocity form, you start at a constant rate of 0.5 meters per second. Then you decrease to negative 3 meters per second, and then you increase back to 0 meters per second. Remember, look at the slopes. Look at the slopes, 0.5, negative 3, and 0, okay? How about level 2? Let's check level 2 real quick, okay? Let's check level 2, and this will be the last thing we'll be doing. Level 2. Let's check at this first one, the first displacement graph. It is at a rate of negative 1 meters per second. So which graph do you think will be the correct one? It's the fourth one, because the slope doesn't change. It's negative 1 meter per second throughout the whole entire graph. Look at that, negative 1 meter per second throughout the whole entire graph. It's negative, so it's going backwards because it's velocity. Okay. How about the second one? We start at 0 meters per second. Then our slope increases to 3 meters per second, but then it decreases back to 0 meters per second. So we go, awesome. Thank you, Lourdes, for letting me know we have 5 minutes left. 0, 3, and 0. So which graph will be appropriate? Will it be graph 1, graph 2, or graph 3? Graph number 1, because it starts at 0. Look at that. Starts at 0. Then it increases to 3 meters per second. You see that 3 meters per second? But then it goes back down to what? 0 meters per second. Good job. How about the last one right here? We start at 2 meters per second. Then we decrease to 0. Then we decrease again to negative 2 meters per second. Is it graph 2 or is it graph 3? Graph 2, graph 3, the one on the left or the one on the right? Left or right? Remember, starts at 2, then 0, negative 2. Look at the slopes. I'm getting rights. I'm getting graph 3. Yeah, indeed. This graph right here. Good job, guys. Good job, scholars. We start at 2 meters per second. Then what happens at 3 seconds? It decreases to 0 meters per second. That only lasts 1 second. And then it decreases again to negative 2 meters per second from 4 all the way to 7 seconds. So it keeps going down. So which means the last one is this one. Oh. Right? Negative 1 meter per second, then 4 meters per second, then 0. Negative 1, 4, 0. Look at this. Starts at negative 1 meters per second, then increases to 4 meters per second, and then decreases back to 0 meters per second. He has a couple of seconds to copy that down. So very quickly, same thing, even though it looks a little bit different, we start at 0 meters per second, and then we increase at the end for 2 meters per second. Look at this, 0, then 2 meters per second. Okay. And on this one, we start at 1 meter per second, and then we go down to negative 1. As you can see, remember, displacement is the object's position, right? So you can say that it's going, and then at 4 seconds, it changes direction. It goes backwards. So right here, this reflects that. Once you cross that x-axis, you're going the opposite direction, okay? So we start at 1 meter per second, and we end at negative 1 meters per second. And then this third one, we start at 3 meters per second, and then we end at 0 meters per second. So we start at 3, then we end at 0. And last but not least, this last one, you're moving backwards, negative 2 meters per second. At 3 seconds, you change directions, and you increase every 2 meters per second. Start at negative 2, end at positive 2. So the key thing is to always look at your slopes. Always look at your slopes. They will save your life. Okay, that's pretty much it. We have about 1 more minute. That's pretty much it. There's no homework for today because it's Monday, Tuesday. All you got to do is just show up to class. So I will see you guys tomorrow. We'll do the scavenger hunt tomorrow.